Hey everyone, in this video we'll be talking about SageMaker Batch Transform, kind of continuing on the inference video series that we've had going. And Batch Transform is the first offline inference option that we'll be kind of highlighting or discussing. And today I won't spend too long in the whiteboard. I think I just want to really quickly overview what were the existing inference options that we've already talked of and what else is soon to come in this series as well. But we'll speak specifically as to where Batch Transform will be useful and what use cases you should consider for. So if you remember correctly, right, within inference, there's 4 different modes in SageMaker at the moment. And that's real-time inference, where you have a persistent REST endpoint with sub-second latency, high throughput sensitive kind of workloads that you want to be tailored for. You can enable things such as auto-scaling here, and you can basically control the hardware. You have full visibility into all of that there. The second mode, which we haven't talked of yet, which is also another endpoint option, is serverless inference, where you basically don't select the capacity behind the endpoint. So it's still an endpoint, and you might deal with some cold starts because it's serverless. You don't have control or visibility into the hardware behind it. All of that's kind of done out of the box for you. And the third one, async inference, is the third endpoint option. And this is actually a bit of a hybrid between real-time and offline inference, and I think this is the one we'll do directly after this video too. But this is another endpoint option. So all 3 of these are actually endpoint-driven options. So they're all going to be REST endpoints that you can basically invoke. And then for inference, the last one, which we'll talk of today, is batch transform. And this is completely offline, and there is no REST endpoint or persistent endpoint that you can invoke on demand. So there's obviously different use cases for the real-time, serverless, and async if you go the endpoint route. I'll link below the original part of this series where we talk about when to use what out of these 3, and we'll also have some hands-on videos with serverless and async as well for just to kind of cover all the different options. But for today, we'll talk specifically about batch. And batch, like I said, completely offline. There is no REST endpoint for you to invoke. You should really only use this inference mode. Let's say if you have a sample model, a sample data set, and you need inference run on that entire data set, and you want an output data set returned at some point or something of that sort. So if you have, for example, your input data laying in S3, and then you just want your output data also dumped to S3, and then obviously you can customize this kind of experience once you get the output in S3 itself in terms of where you want to feed it in your overarching application or things of that sort. But it's as simple as here's my input data set, run this across my model, where's my output, and then output my data. And you're not really thinking about, this is where you're not thinking about latency or throughput or things of that sort. Obviously, there's different factors that can control the duration of the transform job, such as the container or the model that you're using itself. But the premise is that latency and throughput are not really sensitive here. You don't need instantaneous responses. That's batch, and some of the use cases, right, that you might be able to think for it that I really want to cover is maybe something like document summarization, which we won't discuss in this video at least, but something like document summarization, something like maybe like video, or kind of like vision-based processing that might take longer. Things of this sort, right? Basically where you have something that's going to be asynchronous and you're not really looking at any stringent kind of SLAs from a latency or throughput perspective. And now in terms of the inference architecture itself, for batch, it's many of the same constructs, just one new thing that we're going to be introducing. And in terms of these constructs, right, we first have that SageMaker model object, which is just the container and the model data. So this is the exact same as it would be for any of the different inference modes as well that we were talking of. The things that we're stripping out are the SageMaker endpoint config and SageMaker endpoint, because obviously, right, we're not going to have a REST endpoint here, and that endpoint configuration is what defines the hardware or the variance behind that endpoint. So we don't have a need for those constructs here. What we're going to introduce something though is, what we're going to introduce as a new construct though is this transformer class, or this object. And essentially for this transformer, right, you can select the hardware behind this transform job. So when I was saying, right, that you can basically influence the duration of the transform job if you want to, you can basically throw a certain amount of hardware behind this batch transform job. So you can say, give me 3 GPUs for this transform job, that's what I'm allocating. And this is also dependent on your model, right? So if your model is a GPU dependent model, so for example, an LLM, you're going to still need GPU instances to work with LLMs, right? For most of them at least. then you're going to have to pick the appropriate hardware there. So even though you're not selecting hardware for behind an endpoint, you're essentially picking the compute that will execute behind this job. And we'll see these batch transform jobs listed out in the console briefly. But that at a high level, right, is what batch transform at least is. There's not much of a difference from the actual kind of like setup itself than there would be for an endpoint. But this new construct, we'll just walk through it in a notebook now and get a little hands on. So let me hop out of this whiteboard quickly. And what I'll do is I'll come to the SageMaker AI console, which is where we always normally work at. Make sure you have an AWS account, your credentials, whatever you need there. And as always, I'm going to be in this classic notebook instance environment. You don't need a big instance here. You might even be able to get away with a small one here. But what I'm going to do is I've set up this Jupyter Lab environment. You can open this up. Like I said before in this series, you can do this on Studio. You can also do it locally if you want. If you have if you're properly configured to work with SageMaker and AWS. But if we come here, right, in this same Git repo that I've been pushing everything to, you'll see there's a new part for batch transform, basically. And what we'll do today is, let's just take, for example, or for reference, a sample Hugging Face model. So we have this Distilbert Hugging Face model right here that I've linked. And what we'll do is we can take this and try to deploy for a batch transform use case. If you remember, for an endpoint, you can actually click here on deploy. And here for Amazon SageMaker, you'll see the boilerplate code that will let you kind of deploy it to a SageMaker endpoint. You can get a bit of a hint. This is not always accurate, but the instance type normally shows the compute that a model of this size would normally require. In this case with Distilbert, this is a very CPU-driven model. You don't need a GPU instance to host it, and you can see it's not very large in size like many of our LLMs, but you can kind of get an understanding here when you look at the at least initial kind of setup configuration. So we return to this notebook, right? I'm going to set this up. I'm going to be working with the SageMaker Python SDK, which is the higher level wrapper around those Boto 3 API calls for create model, create endpoint config, and create endpoint. These are basically just like, this is basically just simplifies some of the operations and gives some utilities to work easily with batch inference in different modes. So if I take this, I'm going to import Hugging Face model. This is essentially saying Hugging Face container is what we're going to be needing for this deployment. Here's my model ID, and here's my task. And this is once again with Hugging Face, this is simplified just because of the native integration with those containers, with those managed images, right? So here I then specify my Hugging Face model. I say this is my Transformers version, my PyTorch version, this is my Python version. This then in the background, right, the SageMaker Python SDK will know the appropriate managed image to pull down for Hugging Face then. And I believe the model serving stack is MMS behind this Hugging Face model. Keep in mind if you have a specific serving stack that you'd like to use. So let's say you want to use torch serve, or you want to use something like DGL, which is normally the one that I prefer. You can also do that. The container setup is just going to look a little different depending on your serving stack itself. So now that I've done this, I've prepared my Hugging Face model object. This natively, right, the Python SDK, since it integrates here with these Hugging Face containers, it will pull down the model data for that set model ID. So when I specified model ID here and the task, it knows which model data to pull down and the appropriate container within this model object as well. When I'm saying here, here's the environment, that's saying the model data to pull down, and then here's the container versions and things of that sort. And now what I've done, right, is I've made a bit of a mock data set. You can obviously use your own data set depending on your model and your use case. But what I've done here is for batch transform, all the input data is expected in S3. S3 is like a storage service on AWS, and that's what we've used as we've seen with SageMaker, right, for storing our model data, our model weights, and like just other kind of like outputs or things of that sort. It integrates pretty natively here. So I've imported Boto 3, the AWS Python SDK, and I'm basically just going to dump this sample payload that I have here. So right here, this inputs, I'm super happy right now. And what I'm going to say is make 50 copies of this basically and upload all these JSON objects into this S3 bucket right here. So if you see, I've taken the default bucket provided by the SageMaker Python SDK. I've made a subfolder known as batch input, and I've basically passed in all my different JSON objects here. I think I need to double check this, but for batch transform, there's CSV support, JSON support, and JSON line support. And the way I've done this here is I've made a data point or a JSON file for each point of data that I'm working with. Optionally, you can have JSON lines that have all this kind of appended or strung together into its own kind of singular file. That's one route you could go. You're gonna have to change the content type of the transform job later if you go that route, but this was just a little simple, so I went that route, but there's flexibility there in terms of what you're working with. But also check, I'll link the batch transform documentation in terms of the supported types in terms of the content itself. Here, I just wanted to verify that the input data path, this S3 this Python variable I have here with the S3 path, correctly lists all the JSON objects that I've uploaded, so I can validate that. I see my 50 objects there. And now what I'm going to do is I'm going to configure this transform job. So this is where the batch transform specific logic comes in, right? So I'm going to say, here's my output data set. Take that same default bucket, make another subfolder known as transform results, dump all my outputs there basically. And then here, this is where really the magic happens with batch transform, where I say, here's my compute that I have behind it. So I'm going to pick a CPU instance. I know this is not a heavy model and I don't have a large data set. Like I said, there's many factors in terms of the duration of the transform job itself. That includes model latency, your container and serving stack, the model size, the data set size, and things of that sort. So those are all factors you would want to think of if you're configuring a transform job. And optionally, if you really want to have more hands-on ability to tune the latency of it, asynchronous inference is a better option. And we'll get into that in the next video. But here I just set my instance count to 1. I just say I need this instance, and I say this is my output data path where I want to dump it. And I'm going to say the format is a JSON basically. And like I said, if you have a singular file, like a JSON lines file, you can set this to application JSON lines basically. Now that I've configured my transformer object, I'm going to feed in the data, right? So this transform right here kicks off a transform job, and this will take some time, just like how an endpoint creates, because we're basically running inference across the entire data set and provisioning the hardware that you specified. So this input data path is what's containing all my S3 data points that I uploaded earlier, specified the content type, and now we wait for this transform job to happen. And you'll see some pretty verbose logs here. This is basically the container itself, what's happening within it. So I think MMS is being used here, which is a little older for a serving stack. That's why I normally go the DJL or Torch server route. But here we'll just see basically the metrics, those CloudWatch logs and everything in terms of what's happening in the job itself. So here, if you see, you'll notice there's predict time for each data point. There's pre-processing, post-processing. It's kind of chunked it out just pretty neatly for you to understand what's happening. We should be able to see a bunch of successful requests to that dash invocations path that SageMaker looks for, basically. And once that is ran, these logs are really verbose. You can also monitor this in the UI too, by the way. If you come to Inference right here and you click Batch Transform Jobs, you'll see a successfully completed job here. And this is essentially right next to that endpoint part in the inference. So it distinguishes that offline inference and the endpoint driven options. You can see the model that we created earlier. You can see the hardware that we have behind it. You can see our input data where we dumped it, where the output data is lying as well, and things of that sort. And if I return here, if you scroll through these logs after this is obviously a little verbose because I think the entire serving stacks logs are basically omitted there. What we can do is we can parse a transformer object after this has been completed for the output path. So this is where it's lying in S3. If I do a quick ls there with the AWS CLI for the output results, you'll see there's corresponding basically data points for my input. So that's why I kind of like having individual data points. It's just a little easier for me to understand and visualize, but you can go whatever route your application demands here. We list that, and what I basically do is I want to pull this all down locally. So this little Python code right here will basically take it, make a directory for results here, and then basically pull down all those S3 output JSONs here locally. And what I do then is I wanted to parse one of these, for example, right? So I took the 5th data point here, or the 6th data point, I forget where I started numbers-wise, and I basically did that, and you can see there's a positive sentiment, basically. If you remember, the input payload was, I'm super happy right now, or something along those lines. But you can parse your output data, get a better understanding of it, essentially. And you can see this with the different data points, too. It should be the same result because we used basically the same payload, right, across all of them. So we have this listed out clearly here, and you can basically parse these results as you need depending on your application logic. But yeah, at a high level, that was mainly what I had for today's video. I wanted to introduce batch transform for those of you that might have offline inference use cases. This is a really good option. It's not the only option. Asynchronous inference, which we'll talk about more in our next video, is basically gives you a little more control in terms of the latency and throughput if you have more of a hybrid mode than a purely offline mode, and you want to be able to control the scaling of the compute better, then that's another option we'll explore soon come. But batch transform is also a really good route to go. And some of the sample use cases I've seen, I know I explained, but I see a lot of people running batch transform, for example, on a cadence. Maybe at the end of the month, you need certain documents to be processed, or maybe you need some sort of process to happen for ML workflows at a certain cadence, or time frame basically. And that's where batch transform I often see people using within step functions or SageMaker pipelines as part of a more overarching kind of workflow. So lots of different use cases for it there um, in terms of like what you're looking at. So just one of many options within the inference stack, and I hope this gives some more clarity in terms of what batch specifically does. It is a good kind of notebook for you to get started with. And as always, if you have any questions, please feel free to reach out directly to me via YouTube, LinkedIn, Twitter, whatever it is, and more than happy to help and appreciate you all taking the time to watch. If you like the video, it would mean a lot if you could like and subscribe, and I will be back very, very shortly. Thank you, everyone.